go, lesson 3.2. I can prove lines are parallel using AIA, corresponding angles, and same side interior angles. Remember, AIA stands for alternate interior angles. Okay, take a minute and copy that down. This picture looks like yesterday's. We have two parallel lines, we have a transversal, we're creating 8 angles here. Yesterday we started out just like this with parallel lines. Today we're going to prove that the lines are parallel. Okay. I'm sorry. I know where I want to go with that. Just a reminder, we've already talked about, so I'm not going to rehash everything, but we just pointed out, that was my point of the slide, was to point out that corresponding angles are congruent from the corresponding angles postulate we learned yesterday, that alternate interior angles are congruent because of the AIA postulate, alternate interior angles. Sometimes, remember the difference between postulates and theorems? A postulate does what? What do we know? What do we say about postulates? They're a fact, right? That we just accept to be true. And with theorems, we prove them to be true, right? Okay, well, some textbooks approach this differently than others. So from time to time, I may call something a theorem or postulate, and it's the opposite of that in this book. That's because in the old book I taught out of, they were theorems instead of postulates, or postulates instead of theorems, okay? So depending on how the book approached, how the authors of the book approached the information leading up to these, they may call them theorems or they may call them postulates, okay? These are two of the scenarios. These 3 theorems are scenarios where one book called them theorems and another one might call them postulates. I'm actually used to the alternate interior angles as being a theorem. I don't remember if this one called it a theorem or postulate. I think it's a theorem, but I'm not sure. The corresponding angles is a postulate in both books. Okay? And then the other angles that we talked about yesterday were same side interior. And I don't want to beat that up anymore. We just spent 5 minutes at least talking about them. So let's move on now. We're going to talk about the converse of the corresponding angles postulate. I'll give you a moment to copy that down. All right, just to make sure you read my writing, this says the converse of corresponding angles postulate. If corresponding angles are congruent, then the lines are parallel. So in this scenario, if I go back up to the picture, we're saying these are corresponding angles. Angle 1 and angle 2 are corresponding angles. And we're saying they're equal. We're saying that measure of angle 1 is equal to measure of angle 2. Well, this postulate says then that because these 2 angles are equal, then that means these 2 lines must be parallel. Okay? Well, yesterday we went the other way. We said, hey, because these lines are parallel, these lines here were parallel, that meant these angles have to be equal. Today we take the converse of that. Remember what we learned in chapter 2? If a conditional and its converse are both true, we could write it as a what? A biconditional, that's right. We could write it as a biconditional, which means it doesn't matter what fact I'm given, I know the other one must be true. Okay? That's what's special about this postulate today. Okay? It means that given the other information, given the angles are equal, then my lines must be parallel. So this is the converse of the corresponding angles postulate. And it's a true statement also. Okay? Let's move down to the converse of the alternate interior angles theorem. Pause here for a moment and go ahead and copy that. Just to make sure you can read this, converse of the alternate interior angles theorem says, if alternate interior angles, that's what AIA stands for, if alternate interior angles are congruent, then the lines are parallel. So again, it's the converse of the AIA theorem, which said if the lines are parallel, then the angles are equal. In this case, it's saying if we know the angles are equal, then that means the lines must be parallel. So if we go back up this picture, we're saying because these two angles, angle 1 and angle 2, are equal in measure, that means that S is parallel to T. Okay? Because these angles are equal, measure of angle 1 is equal to measure of angle 2, that means then that line S must be parallel to line T. That's the only way those angles could be equal. You can't see this. If you watch this at home, you won't be able to see what I'm doing. I'm taking these two lines, and I'm saying if I turn these lines so that they're not parallel anymore, okay, then these alternate interior angles are not going to be equal, okay? They're no longer equal. This angle down here is not the same as this angle up there, is it? It's obvious when I exaggerate it like this, it's obvious that this angle down here is not the same as the angle up there, okay? But as I make these lines parallel, then this angle down here and this angle up here do look the same, don't they? Okay? So make sure you understand that the only way these lines could be parallel is if these two angles, alternate interior angles, are equal. Okay? I shouldn't say it's the only way because we just talked about corresponding angles also. Okay. Now the last theorem we talked about, I'll move down so you can copy down the theorem, and then we'll slide back up and look at the picture. Okay, again, just to make sure you can read my writing, converse of same side interior angles theorem. If same side interior angles are supplementary, then the lines are parallel. So just like the other two, we're taking the converse of yesterday's theorem, and we are stating that the only way my lines could be parallel here is if these two angles, these same side interior angles, add up to 180 degrees. They have to be supplementary. So we're saying if measure of if we don't have them labeled. So we say if 110 degrees plus 70 degrees equals 180 degrees, then S must be parallel to T. Line S must be parallel to line T. Okay? Since these two same side interior angles add up to 180, then that means these two lines must be parallel. So you see, same concept as yesterday, except now we're taking the other information. Remember I said in our little review, bless you, I said that today we're starting out with lines being parallel. We're talking about yesterday's homework. We start out knowing the lines are parallel, and then because the lines are parallel, these other facts are true. Today we're starting out with these other facts and saying, because these other facts are true, like in this case, same side interior angles add up to 180, because that's true, then that's only true because these lines have to be parallel. So again, we could write this original conditional and this converse as biconditional, and it says that no matter what, if I know lines are parallel, then same side interior angles are supplementary, or if I know same side interior angles are supplementary, that means lines must be parallel. Okay? So here we have two other theorems. They don't have special names. Go ahead and copy this down. It says if two lines are parallel to the same line, then they are parallel to each other. If two lines are parallel to the same line, then they are parallel to each other. and that was if two lines are parallel to the same line, then they are parallel to each other. The second one says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Two lines are perpendicular to the same line, then they are parallel to each other. We have to throw in a plane in here because if we look at the corner of a box, or the corner of the room, along the ceiling, that line and this line over there are perpendicular to the corner line. That doesn't make them parallel to each other. They're actually perpendicular to each other. So in this case, for this to be true, we have to say that we're talking about only lines in a plane. Because if we move it outside the plane, it may not be true. Okay? In the first theorem there, it didn't matter if they have to, we can always make them in the same plane. Okay? So that it has to be true no matter what. But in this case, it's only true if all our lines are in the same plane. And if you've got enough time to copy that down, let's look at a picture of that. Line S, T and R, okay? Line R is perpendicular to line T, and it's perpendicular to line S, okay? And so, what kind of angles are angle 1 and angle 2? They are, but based on the three types of angles we learned in the last 2 days, they are what?
Corresponding.
They're corresponding. And we learned earlier today that if corresponding angles are equal, then the lines must be parallel. So that kind of helps us prove that if two different lines are perpendicular to the same line, then they must be parallel to each other. Okay? So we can use the converse of the corresponding angles postulate to prove that these lines S and T are parallel. Okay? We can do that. All right, any questions on that theorem? Okay, I believe that's it for the notes. Your assignment today, I just looked and now I've forgotten. I think it's like 3 to 69. By threes.
3 to 69.
3 to 69 by threes. Now there is some review in there. But remember, every test is cumulative and it reviews the previous lessons, the concepts that are important. So you need to continue to have a little review.